Usually a teacher will read that big math problem in the beginning of the lesson and think that their students aren't quite ready for it. And it's true, they're not quite ready. That's why you need to take that big, complicated problem and break it up into smaller pieces. By giving them the power to do it on their own, it'll teach them how capable they are of solving things that they would have otherwise thought are just too hard. Okay, so has anybody ever had a problem that is so big that it seems like you cannot do it by yourself? How about cleaning your room? Right? Has your mom ever told you to go in and clean your room and you're like, oh. Yeah. But what if your mom says, hey, go in and put your clothes in a pile? Does that seem so hard? Or go in and pick up your books. Is that so hard?
Yes.
No, sometimes.
I don't even read books.
But you can get to the exact same place doing little steps at a time, right? So that's what our lesson is going to be about today. We're going to learn about computational thinking. So to start out, I'm going to ask you to add some numbers in your head. You said you all know addition, right? Okay, here we go. I want you to add the numbers from 1 to 200 in your head. Ready? Go. You have 30 seconds.
To do what?
Add all the numbers from 1 to 200 in your head. Okay? Go. Okay, is anybody done yet? So how far did you get?
1 plus 200 plus 199 plus 198.
Okay, so not quite all the way. Was that such a big problem for any of you that you didn't even try?
No.
Yeah? So does anybody think they have the actual answer? It was kind of a hard problem, huh?
Okay.
What we were doing is we were adding 1 plus 2.
3, 4, 5, 6, 7, 8, 9, 10.
And then plus
199.
Whew, that's what we were trying to do, right? That's a lot to do in your head, isn't it? But what if I taught you a trick that helped you do it in your head? So the first thing is, add the numbers from 1 to 200 all in your head in 30 seconds. Right? That's hard. That's a big problem. Our first step was to take that big problem and break it down into little steps, right? And then the next thing we can do is we can look for patterns. So does anybody see a pattern? You guys both do. What's a pattern?
So if you add like 1 plus 200, then you'll get 201, and then if you keep going like 2 plus 199, you get 201 too. And then if you add 3 plus 198, you get 201.
Does anybody see that pattern?
Yeah.
Yeah? So you have 201, 201, 201. How many of these are you going to have?
Cut 200 in half, which is 100, and then multiply 201 times 100.
Can I just tell you that you guys all did that in your head?
20,001.
Right? So what does that equal?
20,100. You need a comma. You need a comma.
Thank you. So you guys just took a big, scary problem. You broke it down. You found a pattern. You put it together into an algorithm that you could solve. You did it all in your head. And if you were to do this again, it would only take you less than 30 seconds, I guarantee you. These are skills that you guys can actually use on every problem for the entire rest of your life. And you're going to notice if someone hands you a big problem and you go, oh, wait, that's a big problem. How can I break it up into smaller problems? and then solve one at a time until I figure it all out, you're going to be the smartest kids in your class. You're going to be the smartest people at your workplace. You're going to be the smartest bosses that ever ran a company because you'll be unstoppable. So we're going to learn how to practice that. Okay, so I'm going to show you how to do this, okay? So there's 3 different stories. You need to go through the stories, and wherever they have the same word in the same place, you circle it. And wherever the words are different, you cross them out or underline them, okay? And then at the end, we're going to write down all of the things that are the same, and wherever there was something different, you're going to have a blank. So you're kind of going to make your own, almost a Mad Lib. Do you guys know what Mad Libs are? Yeah, okay. So go ahead and get started, and I'll walk around and help you in case you get stuck. There is an obvious pattern, and teachers like to make sure that the kids pick up on it. But it's enough for the kids to come up with their own thoughts based on the game. So if this group comes up with a different game than this group, it's perfectly okay. Just have them explain their reasoning and let them know where they succeeded or where they could use a little help. So read it out loud to me.
I chose a blank and rolled a blank, then a blank, then a blank. That means I need to draw a blank blank on my blank.
Okay, so now you have to figure out how to play the game based on what you just wrote. So I chose a blank, and they said lion, donkey, and puppy.
And so I can make it mine.
So what do you think is the first thing you need to do? I chose a...
And I gotta choose one, either this one, or that one.
You can choose any of them you want. Okay? So now you know your first step of your game. Okay? And then I rolled a blank, and a blank. So how many times do you think you have to roll the dice?
3.
Very good. So now make up your own rules to the game based off of the instructions.
Okay, so which game?
So now what we're going to do is we're going to think about the game that we just played. You had a big problem. You had to figure out how to make directions to this game. And you needed to break it down into little bits, which you did by having 3 different stories. You had to find patterns. And what were the things that were patterns? What were those? Yeah.
You'd always choose an animal, you'd always roll the dice.
Right, so there were some things that were the same in every story, and you circled them, right? Then we had to use abstraction, which was taking out all the details. Because the things that were different, we wanted to just ignore that till we were ready to create our own story. So what did we do?
Write it down.
We crossed it out, right? And we made an underline there. So we ended up with words and underlines that let us make our own story. And that became our algorithm for creating rules to our game. So this is what we do in computer science all the time. We find big problems, we pull them apart to see what things are the same and what things are different, and then based on what we find out, we can create a solution that works for everything.